Hello everyone, Brandon here again from GD&TBasics.com. We have another question here on a video question line. Today's topic is cylindricity. Today's question is, hello team, can you please explain if a material modifier can be used with cylindricity and why? And this question came from Lokesh. So let's take a look at this real quick. I want to go over the actual cylindricity, how it looks on the wall chart, and then a brief description of cylindricity. I've brought the wall chart in here again. Just wanted to point out here this green area here on the wall chart. This is the area for the form controls. As I've stated before, if you have not downloaded this is a free resource to all of our students. So make sure that you download it. This is a 11 by 17 format. We recommend that you print it out in that and laminate it if you can. If not, you can print it out on an 8.5 by 11, but it's kind of hard to see on 8.5 by 11. The font's pretty small. But looking at this here on form, we have cylindricity over here, and it's the bottom one. So I've circled it here. It's the bottom one. And hopefully you can see this on this screen. If you look up at the top here, though, one of the columns, and this would answer this question real quick, just looking at this wall chart without having to go back through the course to find this out. It states right here in the column, MMC or LMC applicable. So those are the two modifiers. Now, a lot of us do refer to as RFS as being a modifier also, but it's the one that's there by default, regardless of feature size. So when we're talking about the modifiers, we're talking about MMC or LMC. And if you come down here to cylindricity, that's no. It is not allowed on cylindricity. It's also not allowed on circularity. We used to always say it's not allowed on form controls at all, but that's not true. If you come down here to the very bottom, per ASME Y14.5, these symbols are always at RFS, and they have circularity in here, and they have cylindricity in here, but they do not have flatness. So up here we've got the flatness on a derived median plane, and they do not include straightness on there because we have straightness on a derived median line. And on those two, we can use a modifier. And most often we see those with the maximum material condition modifier. So that's why that's not included, that statement about always. But when it comes to circularity and cylindricity, they are always at RFS. So we can never use the modifier on these two. It's not allowed. Just real quick, a refresh here on cylindricity. It's the state of adhering to a perfectly cylindrical form. This one's three-dimensional. It is two cylinders. So it's three-dimensional tolerance zone that covers the entire surface of a cylindrical part. And then the last one there says cylindricity is not very common because it only applies to cylinders and it is fairly difficult to measure. Later on, we're going to talk about, in a different video line question, we're going to talk about how to measure this. We're not going to cover that today. But that one is, if you're a machinist or an inspection, you've ever had to try to inspect this by any other means than a CMM, this can be quite difficult. And quite often you have to cheat in order to do that. So real quick, let's take a look at our example drawing. I have this little sample drawing up here in the top left-hand corner, right up here. So this is my little sample drawing. I know it's quite simple, but for this we don't need a complex part. It, after all, is just a cylindrical shape. On this one they have 20 millimeters plus or minus 0.05. So if we look at the maximum material condition of this, we're going to have 20.5. And for the least material condition, we're going to have 19.5. It is plus or minus 0.5, so we have that total tolerance of 1 millimeter in size. Now, if we didn't have cylindricity on this drawing, then that's what our cylindricity error could be, is 1 millimeter. And if you look at this little illustration I have over here to the right, this value right here would just be 1 millimeter. And that would mean that this distance between these two could deviate all the way up to 1 millimeter. Now, we're looking at the in view here, which looks identical to circularity. And if you guys remember from the course, indirectly, cylindricity is controlling circularity. So from the end, it is going to look identical. But as they show up here on this tolerance zone, it is 2 cylinders. And then that spacing that you see, or that tolerance zone you see on the part, cylindricity of 0.03, that is, as it states right here, how far apart the 2 cylinders are from each other at the outer edges at any given point around this. So now I just showed you the MMC and LMC size on there, and that's one thing that a lot of people get confused about especially in our course when we're talking about maximum material condition or least material condition. For rule number 1, we need to know what those are. Those are not modifiers. Oftentimes people do get those confused with modifiers, and that's not the case. But on this drawing here, they've came back in, they have refined rule number 1, right? They've refined it up here with an actual cylindricity call out, which just means that the engineer in this case just couldn't live with that 1 millimeter of cylindricity error, so they've gone in and they've refined it, in this case down to 30 microns. So I crossed this out a while ago, but it is 30 microns total. That is the distance between those two at this point, but it could be, again, at any given point around here. Because we have 2 cylinders, they're all going to have to pass. So you see the shape here in black. This can happen. Now, granted, the original question wasn't so much about this. It was a pretty simplistic question. The answer was even more simplistic, with the answer just being simply a no. But I wanted to point out here that the size here, in this case, the size is not controlling the cylindricity anymore. We're not relying on rule number 1. We have a refinement here with cylindricity of 0.03. But now if this did come in at 20.5, that would mean our cylindricity error would be 0, or our allowable error would be 0, because remember, perfect form at maximum material condition. So as we depart, we gain by that amount of departure away from MMC towards LMC, and we have to depart by the 30 microns in order to get the 30 microns. So we do have to depart by that amount first in order to get it. But once we've departed by that amount, it doesn't matter how far. We can go all the way down to the 19.5 or the LMC condition. We can go all the way down there. We only get the stated 30 microns of cylindricity. So there is no modifiers allowed on this. No MMC, no LMC. It's strictly RFS, like I said before. Nothing's going to change about that one there. So make sure you don't let the conversations about maximum material condition confuse you with the maximum material condition modifier when we're talking about cylindricity or circularity. The modifier is not allowed to be used, but for every feature of size, we always have an upper limit or a lower limit, or the maximum material condition or least material condition. Okay, that takes care of this for today. I appreciate you guys listening. Again, any questions that you have, send them to questions@gdntbasics.com, and we'd like to answer them for you. You guys have a good day. Thank you.